Welcome to Programming Knowledge. Today I'm going to talk about analog input on Arduino. Okay, let's go. First, we have to know what is an analog and what can it do. Okay, the analog signal is a continuous signal. The analog signal graph is sine, cosine, or any up and down curve like this. And this graph is representation for the analog signal in the physically. And this is a representation for the digital signal. Okay, so but in the real, when we collect the analog signal, it isn't simple or smooth like this, but the signal always noise when we collect like this. Okay, this is the analog in the real life when we collect it. And the application of this video is you can turn LED on or off when you control the potentiometer, okay, or anything can transfer analog, okay. And the analog is quite noisy and it's very hard to save or process, so that is the reason why we have the digital signal. The digital signal only is high or low level like this. Therefore, the analog signal will be converted to the digital signal in order to easily process and saving. Okay, we already know what is the analog signal, and now we will know how to collect it from the peripheral devices by Arduino. On Arduino, we have 6 pins to receive the analog signal. That is from pin A0 to A5 right here on the left side of and the Arduino's analog system has 10 bits. It means it can be converted the analog signal to digital from 0 to 1023 corresponding to 0 to 5 voltage. Okay, it means when you input a voltage signal in this range from 0 to 5 voltage, the Arduino will convert it to a number from 0 to 1023. It is a decimal. Now we'll test the Arduino analog system, and before we do it, we have to calculate the analog value when we transfer input from 0 to 5 voltage to the Arduino. Okay, we will calculate it, and I will use the voltage divider to create a voltage signal. Here, this is the voltage divider. I have 2 resistors. The first is Z1 and the second is Z2. The Z1 is connected to V-in and the other one is connected to ground. And between of Z1 and Z2 is the V-out. When you connect like this, you can collect the V-out with the voltage you want if you change the value of 2 resistors. Okay, this is the formula to calculate the V-out. The V out is Z2 divide Z1 plus Z2, and all of them is multiplied with V in. Okay, and I assume that Z1 is 1000 ohm. Sorry, I forgot to put unit here. And the Z2 is 1000 ohm. The very 5 voltage. And when we apply this formula, we can get the V out is 2.5 voltage. Okay, next is the calculate analog resolution. The resolution is the 10 bits value we will get. Okay, here is the formula to calculate it. The ADC right here means the analog to digital convert. Okay, and digital output right here means the value we want to get. The digital output is 2 power n multiplied with analog input voltage. The analog input voltage is the V out in the reverse slide, and all of them is divided to reference voltage. The reference voltage of Arduino is 5 voltage. Okay, and the n is the number of bits in ADC converter. The n right here is 10 bits. And I have a script right here. The V out is 2.5 voltage. And the N is 10 bits. Reference voltage is 5 voltage. Summary the value like this. Okay, I will calculate it. I will put 2 power 10, then multiply with 2.5, and then divide to 5 is 512. Okay, that's it, 512. Okay, when we input the 2.5 voltage to the Arduino, we can get 512. We have a function to read analog value. We will use analogRead to read the value from the Vin, and the pin right here is the analog pins. Okay, this is a diagram. We have a 1000 ohm and 1000 ohm right here. I will connect 5 voltage to the above resistor and GND to the below resistor, and between them I will take the signal to the A0 pins. Okay, before connect, I will code it. To set up the analog pin, we don't have to set pin mode input like the previous slide. We just need analogRead pin. Here I will use pin A0. Okay, but if you want to bring the value to the serial monitor, we have to set up like this: serial.begin. This is about right 9600, and then I have to bring this value to the serial by this function serial.print, and ln right here is it will bring the value to new line right here. Okay, and I will delay it 1 second. After 1 second, it will print the value once. Okay, now I will connect the circuit. I have a 2 resistor 1000 ohm right here. Okay, I will plug it right this. First, second like this. Okay, like the diagram. Okay, and the red wire I will use for 5 voltage. 5 voltage. And the black wire I will use for GND. GND. And the green wire I will use for the input. I will plug to the A0 pin. Okay, A0 pin. Now I will upload the code to Arduino and let's check. I will connect my Arduino to the laptop. Okay, now upload the code and open the serial monitor. Okay. Okay, you can see the value is 5. Is quite noisy, right? Sometimes it can be lower than the 512. Okay, it's approximate. Okay, I have another sample. I will change the below resistor to 10,000 ohm, and then I calculate to 4.54 voltage, and the value I can get is 931. Okay, you can try it yourself to check. Okay, so through this tool sample, you can apply it to control your LED. Okay, it means if your analog value is lower than 600, you will turn on LED, and if your analog value is higher than 900, you will turn on LED or turn off LED. You can control it like this. Now I have a new sample. Right here, I will use a potentiometer to control it. If my value is higher or lower than the value, I will turn on or turn off the LED. Okay, I will connect the potentiometer like this. The potentiometer, you can use 1 kilo ohm, 10 kilo ohm, or anything you want. Okay, now we'll go to control LED via potentiometer. First, I will config LED 13 is output, and then check the analog value. If the analog value at pin A0 lower than 500, I will turn off the LED. Low. And else if the analog A0 is higher than 900, I will turn on the LED. Okay, and the other, if the analog value from 500 to 900, I will blink the LED. Okay, I have a bracket here. Okay, now I will bring H value to serial monitor to easy check here. Here I will Serial.print up. Here is on, and copy this to here. Copy both of this here. Okay, blink. Okay, if the analog value is lower than 500, we will turn off the LED. If higher than 900, we will turn on the LED. And if the value from 500 to 900, I will blink the LED. And we'll print the value to the serial monitor. Okay, now we'll connect like the diagram. I will let it here. And I have a potentiometer is 1000 kilo ohm, and I have 3 pins. The left is 1, the mid is 2, and the last one is 3. Okay, now I will connect the 1 is to 5 voltage, the mid is 2 analog input pins, and the last one is to ground. Okay, I'll use the red wire for 5 voltage. 5 voltage, and the black for ground. Okay, and the last one to A0 pin here. Okay, and you can see it. Okay, now upload the code and check. Okay, upload and check. I will open the serial monitor to check it. Okay, now I will turn to left. The LED on continuously, and the value is higher than 900. It will turn on the LED. And now I will pull to right. Is lower than 500, so it will off the LED. Okay, the LED here is the TX, is not a 13. Okay, and now I will pull it to the between 500 and 900. Here the value is 663, 667 is between 500 and 900, so it will blink the LED. Okay, the analog input is easy, right? Some next video maybe I will read analog signal from photosensitive module, gas module, and infrared module, or etc. Okay, thank you.